themes of process intensification after covering all these points. So please note it down, the key themes. The first key themes is nothing but the capital investment reduction, energy use reduction, raw material cost reductions, as well as the increase the process flexibility, as well as the inventory reductions. Ever greater emphasis on process safety, increase attention to quality, better environmental performance. So I cover all these points in the intensification. Not a single point is there that we have left it over here. If you have any questions in this, you may ask, so that sessions may more interactive way that we can discuss about the or may any one of the points related to this intensification or integration. I never ask you about what is the difference between the process integration and intensification, and which comes first. That I already said in the first lecture of this course, where that I have seen, or I have raised one question: which comes first? Process integration comes first or intensification comes first? But at that stage, that you don't know about the process intensification, but right now you're getting some sort of a knowledge about not only the process integration, but also little bit knowledge about the process intensification right now. Clear? Have you all noted? Shall I move? So basically, how the intensification may works. So as I said, the equipment methods are there. So generally that you have studied in any of the courses, like generally the majority of the courses are nothing but that you have seen over here, the chemical reaction engineering, heat transfer, mass transfer, fluid dynamics. Okay, जब तक ये सब कोर्स का नॉलेज नहीं आ जाता है, तब तक प्रोसेस इंटेंसिफिकेशन may or may not be started. Okay, I think you already covered all these points: chemical reaction engineering as well, mass transfer, heat transfer, fluid dynamics, process dynamic and control. Okay, once you're getting all this knowledge, the process intensification is the last step. Okay, so that's why the process intensification works in all these things with the help of the basic concept of all these courses. Okay, so like first is nothing but the intensified में works with the help of enhance. अगर कुछ किसी चीज का हीट ट्रांसफर मास ट्रांसफर इंप्रूव करना है, एनहांस करना है, इंक्रीज करना है, that way you need to use over here the basic law or basic funda that is must be clear. That is nothing but the transfer rate is equal to transfer coefficient into area into driving force. Okay, and the method of enhancement is nothing but energy fields. अगर centrifugal है, so in that way you can use the energy fields, electric fields, microwave, inductions, as well as the light. Okay, in that way you can use it over here the energy fields, and that energy fields comes to over here generally in the driving force. Generally in the driving force. Okay, if you improve the driving force, if you improve the transfer coefficient, as well as if you improve the area, obviously your transfer rate may vary and your transfer rate may improve and enhance. In that way the intensification may work. So this is the basic principle over here that you know about. If you must know about the driving force as well as the energy fields or the transfer coefficient, then and then you can improve the transfer rate. Okay, next is nothing but the changing the shape and size of flow channels. Generally it behaves with the areas. Okay, generally if you change the area, if you increase the area, if you reduce the area, as per the area of heat transfer or area of mass transfer is really important in the transfer rate. Okay, in the transfer rate, in the medium rate. Okay, so that is important over here for this particular area as well. Next is nothing but if you're considering the reaction rate, if you need to improve the reaction rate, again you can apply the basic kinetic law equation. Okay, kinetic law equation is there. That way you can applying it. Like over here, the same thing, rate constant into your driving force, and your driving force is nothing but the concentration gradient. Okay, and that you need to apply over here. So minimize or eliminate ideal heat and mass transfer resistance, ideal flow to ensure maximum driving force for reaction, overcome equilibrium constraint, and combine separation as well as the reactions. In that way, generally many of the separation process, many of the reactive process may work in such a way that generally that you're seeing the reactive distillation in the last week, the same thing over here in the reactive distillation may happen heat as well as the mass transfer, because the separation is also there and heating is also there. Okay, and the reaction is also carried out in the single unit, correct, in the middle zone part. Okay, so middle zone part is nothing but over here reaction rate is happening over there. So you need to play with the kinetics. Okay, whereas rectifying as well as the stripping section, the separations may occur, and that separation analogous to your improved mass transfer coefficient or mass transfer rate. Okay, whereas the heat transfer, generally the distillation column itself, the requirement of the heating is there. So each stages or each plates having a different heat transfer or different temperature profiles are there. So that's why all these words or all these principles may applying over there in the reactive distillation is one of the facts. Okay, so that is one of the example that I have shown over here, reactive distillation. There are many more examples are there. Reactive absorption is one of the technique where the reaction as well as the heat and mass transfer may happening. Then membrane reactor is one of the fact is there. I will let you know the what is the concept behind the membrane reactor and many more. Okay, there are many more examples or many more equipments are there. Okay, where that you may see both of these things may happen, either heat and mass transfer, or you may see the reaction rate, or both. Is that clear?